Hi everyone, good morning. So in this video, what we will see is we'll solve one problem on Fourier transform, and using the Fourier transformation, how do we solve this integral equation? I'm sorry, how do we actually find out this integration of some function? That's what we are going to do it today. Yeah. So the question is find the Fourier transform of f of x equal to 1 minus x square whenever mod x is less than or equal to 1 and otherwise it's 0, and hence prove that integral 0 to infinity sin s minus s cos x cos s divided by s cube into cos s by 2 ds equal to 3 pi by 6. Okay, fine. Obviously, without solving without even finding Fourier transformation of f, it's not clearly obvious to solve such kind of integration. So right now, don't worry about actually how this integration comes out, all of them. Just solve the problem. Maybe in future, you will get to know just by experience, right? Most of the time, actually, things comes under experiences. Now, let's solve this problem. Solution. Solution. So we have the f of x equal to 1 minus x square whenever mod x less than or equal to 1. So what is the Fourier transformation of it? Capital F of fx, or in other words, the f of s is equal to integral, not just 1 divided by square root of 2 pi into integral minus infinity to plus infinity f of x into e to the power isx into dx, right? So that's the definition of the Fourier transformation. Now you see mod x is less than or equal to 1 only when if it belongs to minus 1 to plus 1, right? Because it says mod x is less than or equal to 1, meaning anytime you talk about the distance from 0 and x, that should be always less than or equal to 1. That will happen only between if the point x lies between minus 1 to plus 8. So therefore, mod x is less than or equal to 1 is same as that of saying minus 1 less than or equal to less than or equal to 1. So therefore, this particular integral can be now split across three different integrals, where the two integrals already became 0 because mod x is greater than 1 when x lies over here as well as over here, right? So therefore, this particular integration can be simply written as integral minus 1 to plus 1, 1 minus x square. Remember, the f of x value at minus 1 to plus 1 is 1 minus x square into e to the power isx into dx. All right. Okay. So how do we solve this problem right now? Solving is easy because you have the Bernoulli's formula to solve this problem. You see, we usually choose u as something which goes to 0 while differentiating continuously, and we choose the v as the remaining part, right? I'm sorry, we choose the dv as the remaining part. So if you take u is equal to 1 minus x square and dv is equal to e to the power isx into dx, all that we do here in this side is differentiation, here in this side is integration. So therefore, we'll give u dash, it will u double dash, etc. So you will give you minus 2x, it will give you minus 2, and u triple dash is 0. So therefore, all that we have to do is we have to find v, then v1 and v2, and that's all. So v3 is not required to find out. So all that we have to find is v, v1, v2. So then multiply uv, multiply u dash v1, multiply u double dash v2 with the plus, minus, and plus signs. Hence, you will get the formula, right? So this is uv minus u dash v1 plus u double dash v2. So that's what the integration gives you. Now, using all these formulas, of course, that's a 12th standard syllabus, so you would have solved it. Now, what is the final answer? You get it on the integration. So that's the only thing that I will write it now. The final answer is simply minus 2 by s square into 2 cos s plus 2 by s cube into 2 sin s. Okay, so that's the integration. Now what we wanted to do was, yes, of course it works fine if the answer actually is got completed if you had to just find the Fourier transformation of the function, but it has also been asked to find out the integral of sin s minus s cos s divided by s cube. So for that reason, what we will do is we will slightly manipulate this answer here, and then not manipulation, simplify, or maybe whatever you want to call it, expand or whatever it is. So just bring another format of this particular format, and then check that whether that will match the integration or not. Okay, fine. Now how do you do that? Simple. All that I'm going to do here is I'm going to use this formula 2 cos s is equal to e to the power I theta plus e to the power minus I theta, correct? Hopefully it looks similar to you. So similarly, we also have 2 sin s, which is e to the power I theta minus e to the power minus I theta divided by I, okay? And probably you would have learned this formula as cos s equal to this term divided by 2, sin s equal to this term divided by 2i, whatever it is. So this is the formulas. So because of this, you can replace this 2 causes with this e to the power I theta plus e to the power minus I theta. Done. Yeah. Then you can replace 2 sine theta by e to the power I theta minus e to the power I minus I theta divided by s. And then further simplify it. Then you will get one more term where you can find out finally this expression. 1 divided by square root of 2 pi, I'm sorry, 4 divided by square root of 2 pi into sine s minus s cos s divided by s cube. Okay, so that's the expression that you will get. Remember, after simplification. So here also is a little bit of simplification is left out. Okay. Now what we wanted was we want to find the integral, right? So the integral whatever has been given over here, that's what we have to do it. So for that, what we will do is we will use the inverse Laplace transform. So what right now we have is f of s. Okay, so that's the f of x. Now in the first lecture itself, I have talked about integral Fourier transform pair. So if you are known to f of s, then you also known to inverse transform of f of s as well, right? So let's write that. So it's to find the value of the integral or the given integral, we use inverse Laplace transform, meaning we'll write the f of x as 1 divided by square root of 2 pi into integral minus infinity to infinity Fourier transform of f of x into e to the power minus isx into dx. Refer to the first lecture video, and that should clarify these things. Now because of this, what we can do, because of this we can write this is equal to 1 divided by square root of 2 pi into integral minus infinity to infinity 4 divided by square root of 2 pi into sine s minus s cos s divided by s cube, right? So this is coming from the Fourier transformation of f of x. Just now I have written here at top. And using this, and of course further into e to the power minus isx into dx. All right. Now how do you solve this problem? You know, e to the power minus isx is nothing but cos sx minus I sin sx. So just put it together. So therefore this is going to be equal to, probably I can pull all this constant outside. So here 4 is a constant, so I can pull it outside. Square root of 2 into square root of 2 will give you 2. So these two together will get cancelled with this by 2, and then this will be square root of pi, and square root of pi will be just simply pi. So therefore this is going to be 2 by pi into integral minus infinity to infinity sine s minus s cos s divided by s cube times, now I can write this as cos sx minus I sin sx into dx. Okay, now it became a familiar term to work with, and therefore of course you can split it together, right? So this one you multiply with this and distribute this, multiply this, and hence you get f of x equal to 2 divided by pi into integral minus infinity to infinity sine s minus s cos s divided by s cube times cos sx minus I into 2 by pi integral minus infinity to infinity sine s minus s cos s divided by s cube times sine sx dx. Okay, so that's my integration. So now one thing we'll note out is the function whatever we have written here in the integrand over here is an even function. Why is that so? Because you see that the sine is an odd function, cos is an even function. Now if you substitute s by minus s, you get, of course, this is an odd function, and this one will become s is a single function, right? So this is an odd function, and odd into even will give you an odd function. So odd minus odd function, that will give you another odd function divided by this is an odd function, and therefore this division is going to give you an even function, and this is an even function. Therefore this fraction is an even function times an even function. So together, all together, all of them will give you an even function. Hopefully this justification is over. If it is justification is not clear for you, all that you have to do is take this as g of s or any other function, then substitute s by minus s and try to prove that g of minus s is equal to g of s itself. Okay, so therefore this is an even function clearly. Now can you check what about the other side? You see that this is an odd function and this is an odd and this is an even. So therefore this together is an odd function. Odd minus odd is an odd, and this is an odd function, and therefore this will become an even function. But this is an odd function, therefore this term which was an odd function, which was an even function, which gets multiplied with an odd function, so therefore together, altogether, it will become an odd function. Hence what's happening over here is this integration, since because it is from minus infinity to plus infinity, I can right away write this complete integration goes to 0. So therefore now we can write this as 2 divided by pi, since this is an even function, so this is 2 times integral 0 to infinity sine s minus s cos s divided by s cube times cos sx into dx. Of course I forgot dx here, please write it out. And this one is 0, so I can leave it out just like that. Hopefully that justification is over. If it is not, please try to write it as a function, then substitute s by minus s and clarify this answer. Okay, so what we got now finally? So finally what we got was, so this is my f of x, put that in mind. Yeah, so what I wanted was the integral over here. Now this is a similar technique that what we have used in previous transformations. So all that we will do is, in fact, in the deduction process of Fourier series, what we do is we'll substitute x equal to some values, because this particular function, whatever we have written, is valid for every x which is in the domain of f, right? So what we will do is, let's take a particular particular x value, so that it will give you the value of the function for us. Okay, so what we will do is, I know that this integral is valid for every x, so if x equal to 1 by 2 also, it is valid. That's the idea. So let x equal to 1 by 2, therefore implies, we'll not substitute in this right hand side, so we'll say simply f of 1 by 2. Remember, f of 1 by 2 is belongs to 0 to 1, correct? Meaning 1 by 2 is just between 0 to 1. And in this portion, the function value is x by x square. So the function is continuous, differentiable, everything is there. So I don't have to worry about discontinuity at this point. So right now I have to worry about the continuity. The function is actually continuous here. So f of x value, right, can be found out just by substituting x equal to 1 by 2 in f. So the f value at this point was 1 minus 1 x square, so which means 1 minus 1 by 2 whole square, correct? So therefore this is 1 minus 1 by 4, which is 3 by 4. So the f of 1 by 2 value was 3 by 4. Okay, fine. So therefore, and the right hand side, what about the right hand side? In the right hand side, you see that there is only one place there is an x value over here. And if you replace that by 1 by 2, you will get cos s by 2. That's all. So therefore, what we get here is 3 by 4 is equal to 2, actually here 4 by 5, right? So this is 4 by pi, integral 0 to infinity, yeah, sine s minus s cos s divided by s cube into cos, remember it was sx, but x is 1 by 2, so cos s by 2 into ds. Okay, so therefore this implies my integration 0 to infinity sine s minus s cos s divided by s cube into cos of s by 2 into ds is equal to 3 times pi into 16, right? I mean, sorry, divided by 16. So 3 pi by 16. So this is the answer. Yeah. Hopefully the problem is understood. Please revise back once again if you are actually need a little more clarity. So pause wherever is required and then try to clarify the things. Try to solve the things in between whatever I have left it as an exercise. All right, I'll see you in the next video for more problems. Thank you guys.